Hi there. Welcome to Math Meets Mastery with Nana. Today I will be talking about simplifying radicals. So the plan for the lesson is to kind of introduce radicals. What are radicals? And then talk about simplifying radicals using the product rule and then the quotient rule. So let's get started. Okay, so we all know expressions like 2 squared. So 2 squared, we can evaluate this. 2 squared is 2 times 2, and so that's equal to 4, okay? We also know something like x squared, right? Where x is just a variable, and x squared is, as we know, x squared, okay? But what if you wanted to find, you started with 4, or you started with x squared, and you wanted to figure out what number or what variable you multiply by itself to kind of give you 4, or what variable you multiply by itself to give you x squared, okay? So in this case, we all know intuitively that this 4 is either 2 or negative 2, right? Because negative 2 squared gives you 4, and then 2 squared also gives you 4. And with x squared, we also know that it's x, or even negative x also works. If you square this, you should get x squared. Okay. So with radicals, we're sort of reversing what we do when we square a number, for instance, 2 squared or 3 squared, or when we raise a number to a different power, like the third power, fourth power, fifth power. We can kind of undo it with the radical. Okay, so that's what we're doing. And so let's look at some terms here. Okay, so let's say I have, I know that, let's say 3 squared is equal to 9, okay? And I kind of want to reverse this. The way I would reverse this is to have this and put the 9 inside. And this is where we get our terms from. So this symbol here that you see here, this is the square root symbol. And this symbol is called the radical. What's under the radical, whether it's a number or a letter or a combination of numbers and letters, is the radicand. Okay? And then together, this forms a radical expression. Now, another term that I haven't put on this list is the root. Usually there's a number right here. If there's no number here, it's assumed that you're taking the square root. So in that case, you're looking for the number which when it's squared gives you 9. A number that's squared that gives you 9. That's what you're looking for. But if you see, there's instances where you see numbers here like 3, like you could have 3 or 4. In that case, you're finding the root, the third root or the fourth root of that number. So that means in this case, for instance, if you have this, it's a number that when you multiply it by itself 3 times, you get 8. In that case, it's going to be 2, because 2 times 2 times 2 is 8. That's what we mean by this, okay? But in this lesson, I won't really talk about the end root. I'll do that in a different episode, a future episode, but I just wanted to introduce that for now. Okay, so let's look at the last term, the principal square root. So for the principal square root, if you have something like this, square root of 4, we all know that this is 2, right? But remember when I was saying it earlier, we have 2 squared giving us 4, but we also have negative 2 squared giving us 4. And this way, just so we know the square here is affecting the negative as well. Okay, so we know this. So why is it that I'm saying that square root of 4 is equal to 2, not plus or minus 2? It's this idea of a principal square root, is that when you see the square root symbol written this way, it's actually asking for just the positive square root. And so that's why this way of writing, or the symbol here, is referring to 2 and not negative 2. So anytime you see this, either like square root of 9, square root of 16, this is referring to the positive square root. So in this case, you'd get 4, and then in this case, you'd get 3. Okay. Awesome. Let's move on to the next slide. All right, so let's evaluate the following. We're still on just kind of like an intro to radicals. So let's evaluate the following. Well, what is the square root of 36? So remember, square root is the opposite of squaring. So we want a number which when you square that number, you get 36. So we all know that this is 6, right? Because 6 times 6 is 36. Okay, so 6 is our answer. Awesome. Let's try this one. So we have square root of 49 and then square root minus square root of 25. Well, we know that 7 squared is 49. So square root of 49 is going to be 7. Awesome. And we know that 5 squared is 25. So this square root of 25 is going to be 5. That means 7. Then we have 7 minus 5, which is 2. And so that should be our answer. Awesome. Let's try this one. Okay, so what about this one? All right, so square root of 121. So this is where like your multiplication facts are going to be very important, right? Because if you can't look at these and recall them, it's going to be a little bit hard for you to kind of figure it out. But from what we know from our multiplication facts, 11 squared gives us 121. 121 is a perfect square. So square root of 121 is going to be 11. And then square root of 64, we know 8 times 8 is 64, so that's going to be 8. And so when you add these up, you get 19. So that gives us 19. Awesome. All right. Okay, so now, so far we've had separate radicals, right? We've had this one, or separate radical expressions, I should say. So we'd had square root of 49 minus 25. These are separated. Now we have one thing under the radical, right? One big thing under the radical. So let's add that up. So in this case, we can't do it the way we've been doing the others. So with the others, we were finding like square root of 121 separately from square root of 64 and then adding them. But in this case, we don't have that here. We have both of them together, the sum of them under the radical sign. So what we have to do is we actually have to add them first before we can apply the radical sign. So 144 plus 25, that's going to give us 169. And then we put our radical sign. So now we have to find the square root of 169. And the square root of 169, if my memory serves me correctly, that should be 13. All right, cool. Let's go on to the next slide. All right, true or false? Square root of 100 is equal to plus or minus 10. Okay, let me give you a few seconds to kind of think about this. Okay, so if you answered false, then you are right. It's not true. If you remember from one of the earlier slides, I said that this symbol here, when you see it like this, like square root of 100, you're referring to the principal square root. So you're only referring to the positive root. And so this square root of 100 is actually 10, even though 10 squared is equal to negative 10 squared, and which is equal to 100. So this is actually just 10, okay? All right, so let's try this one. This question says the square root of 16 plus 9, where with the 16 plus 9 under the square root sign together, right, is equal to the square root of 16 plus the square root of 9. So let's test this and see if it's true, okay? So remember how we work with the left-hand side. We have to evaluate what's under the radical, what's inside the radical, before we go ahead and apply the radical. So 16 plus 9 is 25. So we're going to have the square root of 25. Okay, here we can do them separately because they are separate, right? So square root of 16 is 4 because 4 squared is 16. Square root of 9 is 3 because 3 squared is 9. So we have 4 plus 3 is 7 on the right side. But look at the left side. Square root of 25. 25 is a perfect square, but remember 5 squared is 25. So this is actually 5, okay? 5 is equal to 7. No way that is not true, right? So this is false. This is false. So this is actually a really good lesson that with adding and subtracting square roots, this, let's say you have a minus b, is not necessarily equal to square root of a minus square root of b. No, neither is a plus b. And when I say a and b, they're just random numbers, right? Or letters, it doesn't matter. Is not equal to square root of a minus square root of b. Oh, sorry, plus square root of b. They're not equal. So that's an important principle to keep in mind. Okay, let's move on. All right, simplifying radicals. We're using the product rule. So here, if you have, let's say, a radical here, And this kind of goes in opposition to what we just talked about, because we said with addition and subtraction, doing it under the radical sign is not the same as separating out the radical expressions. But with multiplication, it's actually the same thing. So when you have two things under the radical sign that are multiplying each other, you can actually separate them and have each have its own radical sign symbol, right? So that's what we're going to talk about. So usually what you want to do is you want to factor out perfect squares. So if you see a number, you want to figure out if there's a perfect square in there somewhere, and then you kind of factor that out. And you break down the radical expression into separate radical expressions using this product tool here, right? And then you simplify the result. Okay, so let's get started and try an example. Okay, so here I have simplify the following radicals. Okay, this is very helpful because sometimes we don't know like what the square root of a big number is, but we can actually break it up using this product tool. Okay, so what's an easy way to break up square root of 500? Well, or 500. Well, 100, right? That's an easy number to kind of work with. And I know that 500 is 100 times 5, right? So this is actually equal to that. I've broken it up. Okay, now I'm going to kind of separate these using the product tool. So according to the product tool, square root of 100 times 5 is the same as square root of 100 times square root of 5. Okay? All right. And the reason why this is actually helpful is because we know the square root of 100, right? 100 is a perfect square. And the square root of 100 is 10, right? Because 10 squared is equal to 100. So this is 10. And then we have times square root of 5. Now we don't know, square root of 5 is not like a rational number. Okay, so we're gonna leave square root of 5 this way, and we're gonna write our answer as 10 root 5. And that's our answer. We're gonna leave it this way because we can't further break down easily break down the square root of 5. Okay, and then you can see that I took out the multiplication symbol. Yes, it's kind of like when you have 2x, you assume that it's 2 times x. It's kind of similar to that. Here, you assume that this is 10 times square root of 5, so you can take that out. Okay, awesome. Let's try another example. So here I have the square root of 2,880. All right, so I'm going to break this one down as well. Let's see. So I see 2,880, and I see 288. That's something that looks kind of somewhat familiar, but let's say I can't really like figure out what's going on here. I might want to like break these up a little bit and see what happens. Okay, so what's an easy way to kind of break this up? This is an even number, so I'm going to use 2. Okay, so 2 times 1,440, right? That looks about right. Okay, so let's see if this rings a bell. This brings something to mind. Now look at this. This is 144, right? So remember, 144 is a perfect square, right? It's 12 times 12. So maybe I can kind of break this up to kind of isolate to kind of pull out or factor out the 144 so that I can continue breaking this down. So this is the same as 2 times 144 times 10. Which is awesome. Now I can use the product tool to kind of take out the 144. Okay, so this gives me 144 times 2 times 10, okay, based on the product tool. Awesome. All right, so I know the square root of 144 is 12, so I have 12 here. Now, in here, is there a way to further break down 2 times 10? Well, I know 2 times 10 is 20, and I know that that includes a perfect square in there because I know that 4 times 5 is 20. So I can further break that down into 4 times 5, right? And then that gives me, now I can pull out my 5 as well. I can't pull out my 5. I can pull out my 4 because I know the square root of 4. That's a rational number. So I'm going to pull that out. So I have 12 times square root of 4 times square root of 5, right? So I end up getting 12 times 2 because 2 squared is 4. So 12 times 2 times square root of 5. Okay, so that gives me, I'm going to write it right here, 24 root 5. And I can't break down the root of 5 into a rational number, so I'm going to leave it like that. And my answer is going to be 24 root 5. Okay, all right. So I clearly did not budget the space right, but let's continue with this one. So here I have the square root of 25x squared y cubed. Okay, so 25 is a perfect square, so that's looking good. X squared is a perfect square, right? Because x times x is x squared, so that's a perfect square. What about y cubed? So if I think about it, y cubed can actually be broken down, right? Because y cubed is actually equal to y squared times y, right? And if I have y squared is a perfect square, so I can kind of take that out as well. And so I'm going to break it down this way. So remember with these exponents, when you have two, I guess, you have two expressions multiplying and they have the same base, then you can add up the exponents. So in this case, y and y are the base, is the base here. Y is the base. And so you can add up 2 and then here is 1. So that gives you 3. That's why we have y cubed. Okay. All right. So let's go back here. So let me break this up, right? So I have square root of 25 x squared. I'm going to keep it there. And then this times, let's see, y squared times y, okay, times y. Okay, now I can kind of break this one up as well into y, square root of y squared times square root of y. And then here I have square root of 25x squared, okay? So if I'm taking away, I'm finding the square root of 25x squared is just 5x. Because 5x, if you multiply it by itself, you get 25x squared. Okay, the square root of y squared is just y. So 5x times y times the square root of y. So this gives me 5xy square root of y. Okay, all right, and that's about it. 5xy square root of y. Okay. All right, so I just want to mention something really quickly. I have been using this dot and kind of this symbol to represent multiplication, this dot and this symbol to represent multiplication, and they both represent multiplication. So I don't want to get you confused. Sometimes I use that interchangeably, but they're all referring to multiplication. Just so we don't get confused with the x's, you know, because that can get confusing. Okay, next slide. All right, let's reverse this. Okay, so sometimes you're going to have to reverse the product rule. So let's look at this example here. So we have for x greater than 0, so for some x greater than 0, the square root of 32x times square root of 2x, okay? And so we're supposed to kind of evaluate this. Well, square root of 2 is not rational. So this doesn't really look like it's kind of easy to work with, right? But if you look closely, you see that 32 times 2 is 64. And 64 is a perfect square, right? Because 8 squared is 64. And then we have x's here, x here, x here. So we can reverse the product rule. So remember, the product rule says if you have a times b, this is the same as a separately, the radical times b, or radical, two separate radical expressions. Okay, so with this one, I have something that looks like this, and I want to reverse it and put it back here to make it easier for me. So sometimes that's what you have to do. So let's do that. Let's reverse it. So this square root of 32x times 2x, according to the product rule, this is equal to square root and everything under the square root. So 32x times 2x, okay? So this is perfect, right where I want to be, because 32x times 2x is going to give me 64x squared. Awesome. And now I can find the square root of that, right? Square root of 64 is 8. Square root of x squared is x, right? If I square 8x, I get 64x squared. So that's my answer. So pretty cool. All right, let's try this one, okay? All right, so again, might not necessarily be easy to kind of identify this. There are two ways that you can kind of solve this. You can kind of reverse this product rule and kind of figure out if the number that you see combines to is a perfect square, and then you can easily do it that way. Or you can actually break this down as well. So let me choose to break it down, because I don't necessarily know whether 45 times 5 would give me a perfect square unless I actually multiply it out. But it looks like I can simply break up 45. So let's try that. So for square root of 5 times 45 is 9 times 5. So we have 9 times 5. Okay, so things are going to check out for us, right? Because we know the square root of 9 is 3, and then we're going to have 2 square roots of 5. And so once we do that, we're going to have, we're going to be able to get rid of the radical symbol completely. Okay, so let's further do that. So we have square root of 5 times square root of 9 times square root of 5. Okay, this is perfect. So square root of 9 is 3. Okay, so we can write that times. Now square root of 5 times square root of 5, this is just going to be, what do you think? If you guessed 5, that's correct. So square root of 5 times square root of 5 is going to be 5. And so this gives us 3 times 5, and this gives us 15. Okay, so another way that you can think of this square root of 5 times square root of 5 is to think of combining them, right? Square root of 5 times square root of 5 is actually square root of 25 if you use the product rule, and square root of 25 is 5. Okay, so you end up with the same thing. So that makes sense. Okay, all right, so we have that done. So yeah, anytime you square a square root, you get the number you get the radicand. So square root, for instance, square root of 3 times square root of 3 is going to be 3. Square root of 8 times square root of 8 is going to be 8. Anytime you have that, you get the radicand. Okay, good. So now we have that done. Now I just wanted to point out that if I wanted to reverse the product rule here, so square root of 5 times square root of 45. 5 times 45 should give me 225. Okay, so this actually square root of 225. And if you're familiar, you can automatically see that this is a perfect square if you're used to kind of working with perfect squares, and the square root of this is 15. So that's also another way that you could have solved this, but there you go. All right, so let's move on to the next slide. Okay, simplifying radicals with the quotient rule. So sometimes you're going to simplify radicals with the quotient rule instead of the product rule. Or sometimes you're going to use a combination of both. So let's talk about this one. So to simplify, when you have a fraction under the square root symbol or under the radical, you rewrite the problem as a quotient of 2 radicals. So in this one, you can see that demonstrated here. Square root of a over b is equal to square root of a over square root of b. You simplify the numerator and the denominator and simplify the result if necessary. All right. So let's continue. All right, so let's try this out. So according to, I'm just going to write that right here. So we have square root of a over b is equal to square root of a over square root of b. All right. So let's see, let's apply that here. So that gives us, if we were to kind of apply the quotient rule here, we would get square root of 7 over square root of 49. Okay, now this becomes manageable, right? The square root of 7 is not going to be rational, so we're going to leave that at square root of 7. And the square root of 49 is 7. So we can leave this answer as square root of 7 over 7. Yep. Okay. So let's try that. Let's apply this here as well. So with this one, we're going to apply the quotient rule. So this gives us square root of 36x squared over square root of 45. Okay. All right. So let's apply that here. Square root of 36x squared. Well, 36 is a perfect square, so it's x squared. And square root of 36x squared is just 6x, right? Because 6x all squared gives you 36x squared. Okay. And then for the bottom, we're going to split this up because 45 is not a perfect square. But we can use the product rule to say that, okay, 45 is equal to 9 times 5. Okay. So splitting this up using the product rule again, we can have square root of 9 times square root of 5. Okay. And so that gives us 6x over that. And then we have 6x over square root of 9 is 3. And then square root of 5 we're going to leave as a rational, 3 root 5. So this gives us 6x over 3 root 5. Now there's a, usually you want to leave your answer without radicals at the bottom, but that's a different topic that we're gonna talk about. Okay, so that's kind of rationalizing your denominator, but or your expression. So we're gonna talk about that in the future. So I'm gonna leave my answer this way for now. Okay, so now let's look at this one. This looks like super complicated, but we can do it. Let's try. So we have square root of 49 times m raised to the power 15 times y, all divided by 8 times m raised to the power 25. Okay, so let's kind of simplify this before we actually apply our radical. Because you see m on top and m on the bottom, we can actually like simplify this, the stuff under here before we apply the radical thing. So let's try and do that. So m15, so m15, remember m raised to the power 15 is like m times m times m times m 15 times. M raised to the power 25 is m times m 25 times, okay? So you can imagine that if you were to actually write these out like m times m blah blah blah, you would have some of the m's on the top canceling some of the ones on the bottom, okay? So all the ones on the top will get canceled out because there's 15 of them. So they'll cancel 15 of the ones on the bottom, and you're going to be left with 10 of the m's on the bottom. So that gives us 8m10, and all your m's would be gone from the top. So you have 49y, okay? Another way to think about this is to apply just the rule for kind of dividing numbers with exponents. So if you have, let's say, m to the 15 divided by m to the 25, it's actually equal to m 15 minus 25, okay? And then this gives us m to the negative 10. The way m to the negative 10 works is it doesn't make m a negative number. No, not at all. So instead of m to the power 10, you have 1 over m to the power 10. That's what the negative means. If you haven't talked about this yet, that's fine. The way I explained it here the first time should work as well. But I just wanted to show you how it also works out algebraically. Okay, so I have square root of 49y, then m to the 10. Divided by 8 times 10, m to the 10. It's a mouthful. Okay, so let's see. So now I can apply my quotient rule and kind of break this up. So this gives me square root of 49y over square root of 8m10, okay? Awesome. So let's further break this one up. So I know square root of 49, that's 7. So this is going to give me 7 square root of y. Okay, so I'm done with my top. Now with my bottom, I can kind of break these up, right? So let's see. 8, I write 8 is equal to 4 times 2. So that can help me. So I have square root of 4 times square root of 2, right? That gives me square root of 8. And then I have square root of m to the 10, okay? All right. So is there a way to break up m to the 10? Okay. So remember, with these exponents, you're trying to think of some number or some expression that when you multiply it by itself, you get m to the 10, okay? So if you think about it, that is going to be m to the 5. M to raised to the power 5 times m raised to the power 5. Remember, when you're multiplying these with the same base, you're going to add up the exponents. So this, you're going to keep the base. So this is going to give us m. You keep the base, and then you add up 5 plus 5 is 10. Okay, so the square root of m to the 10 is actually m to the 5. Okay, so if I simplify this, I get 7 square root of y over square root of 4 is 2. So I get 2 root 2 times m to the 5, okay? So rewriting this, I actually get, and I'm going to use a different pen to write this so I can write it at the bottom here. So here I actually get 7 root y over 2m to the 5 square root of 2. And that is that. That's my answer. All right. So again, I'm not going to rationalize this. I'm going to leave the square root in the bottom because we haven't talked about that yet. All right. So this brings us to the end of our lesson. I have another lesson that's upcoming. It's going to be on adding and subtracting with radicals. So stay tuned for that. Thank you so much for watching and have a wonderful day. All right.